Let us evaluate the integral of cosecant to the power of 7 of x. Firstly, whenever you are dealing with an integral of a cosecant and your exponent is an odd number, you would first need to factor out 1 cosecant squared of x, making this the integral of the left out cosecant to the power 5 of x multiplied by the factored out cosecant squared of x and copy dx. And the next step in here would be to integrate by parts. The general formula for this would be the integral of u multiplied by dv would be equal to u multiplied by v minus the integral of v multiplied by the derivative of u or du. And for our case, this one, the reason that we had factored out a cosecant squared of x, it is that we would group it into the dx in here, making this our dv according to the formula, and cosecant to the power 5 of x would be the u. And with that, let us now take or find the value of v and du. U here be cosecant to the power 5 of x. Taking the derivative, firstly it is according to the chain rule because we have an exponent, making this 5 cosecant 5 minus 1 would be 4 of x. And now that you had taken the derivative of the outer side, take the derivative of the inside, which is cosecant of x. The derivative of cosecant of x would be equal to negative cosecant of x multiplied by cotangent of x. Simplifying this, the negative side, we can put it in here. And cosecant to the power 4 of x multiplied by itself would be equal to cosecant to the power 5 of x, and copy the rest, which is cotangent of x. And put dx whenever you are taking a derivative. So this would be your final du value. Next up would be to take the integral of dv, which is the opposite of what we did here earlier. dv right here would be equal to cosecant squared of x of dx. The integral of cosecant squared of x would be equal to negative cotangent of x. Now that we have all our values now, we can now substitute it according to our formula. U here in this case be cosecant to the power 5 of x. V here would be equal to negative cotangent of x minus the integral of v, which is negative cotangent of x, and multiply this by du, which is this one. I will just be putting right below it since we don't have any space. So this would be negative 5 cosecant to the power 5 of x cotangent of x of dx. After substituting this, we can now erase this. And the next step would be to simplify this expression first. We can put the negative on the left side, making this negative cosecant to the power 5 of x multiplied by cotangent of x minus the integral of, we can see here, when we multiply a negative and a negative, it would result in a positive. And we can just copy 5 here first. And cotangent of x multiplied by cotangent of x would result in cotangent squared of x. And what's left would be the cosecant to the power 5 of x and dx. For this one, we can put 5 outside the integral since it is a coefficient. After this one, take note of the cotangent squared of x here. We would need this to be transformed into its trigonometric identities, which corresponds to our cosecant. which would be equal to cotangent squared of x be cosecant squared of x minus 1. Since what you already have here would be cotangent squared of x, we can directly substitute it. So this would be cosecant squared of x minus 1 and multiply it by this one. And we can distribute this one on the parenthesis. Multiplying this two, it would result in cosecant to the power of 7. After that, we can split this integral into two parts. For the first part, it would be negative 5 integral of cosecant to the power 7 of x of dx. And for the second one, you can see here, it is negative 5 multiplied by a negative sign, which would result in a positive 5 integral of cosecant to the power 5 of x of dx. In this point, you can see here that we have an integral of cosecant to the power 7 of x, which is the same as our original problem. So we need to get rid of this one. Keep in mind that our original problem is exactly the same as this term right here. We had just modified it. And so we can equate this to each other. This would be equal to this one. Now that we have this, we need to get rid of this value right here. We need to add 5 integral of cosecant to the power 7 of x of dx to both sides. And by that, adding this together, keep in mind that this always has a coefficient of 1. 1 plus 5 would be 6 integral of cosecant power of 7 of x of dx be equal to this one. And for this second term, it would result in a 0 or a cancellation. And what you're left with here would be this one. After that, we need to get rid of the 6 coefficient in here because remember, we only need this problem. And by doing that, we can divide both sides by 6. Which would then be cancelled out in here, making this the original problem. And for this one, we can rewrite this as negative 1 over 6 cosecant to the power 5 of x cotangent of x plus, in this one, since we had a coefficient here, this would be equal to 5 over 6 integral of cosecant to the power 5 of x of dx. And by this point, this first term is already been simplified, so we can leave that alone. And let us focus on the second term, which has an integral. You can see here, it is the integral of cosecant to the power 5 of x of dx, which is the same condition as our original problem, wherein it is an integral of cosecant and the exponent has an odd number. So by that, we can just repeat the same steps that we had did earlier. But in this video, I will just be putting the full answer to which what I did in my previous video. So you can watch that if you want to see the step-by-step process. This bracket would represent the integral of cosecant to the power 5 of x, which is equal to negative 1/4 of cosecant cube of x, cotangent of x, minus 3/8 cosecant of x, cotangent of x, plus 3/8 natural log of the absolute value of cosecant of x minus cotangent of x, and add the constant of integration. And now, for the final answer, we can just distribute 5, 6 among these three. And for our final answer, it would be equal to negative 1/6 cosecant to the power 5 of x, cotangent of x, plus 5/6 multiplied by negative 1/4 would be equal to negative 5/24 cosecant cube of x, cotangent of x. 5/6 multiplied by negative 3/8 would be equal to negative 15/48 cosecant of x, cotangent of x. 5/6 multiplied by a positive 3/8 would be equal to a positive 15/48 natural log of the absolute value of cosecant of x minus cotangent of x. And of course, don't forget to add plus c. Let me just rewrite this in here. And for your reduced term, we can reduce this to 15/48. We can reduce this to 5/16. Same as true with this one. And this would be your final answer for the integral of cosecant to the power of 7 of x.